divided by 100 raised to the 3. Okay, so let me show you what I'm getting. Well, one of you guys please hit the lights for me. Whoever would like to, that'd be one. What's going on here? All right. All right, we're cleaning the air filter and then we're going to get started, right? So here's the problem as I set it up into my calculator, all right? 4.5 times 10 to the 4th, and then I'm going to have to multiply by 12 raised to the 3rd. All right, you guys all have this in your notes. Times 2.54 raised to the 3rd divided by. Now, why did I hit a divide there? Because I'm dividing, right? You got to go to the denominator. A lot of people put a multiply sign in here because, see, they think that the calculator sees the problem, and they think that all you got to do is hit the multiply sign. No, you have to multiply by 1 over that number, which is, of course, the same thing as dividing. So you should get 1,274 cubic meters. Now, this lady here had a question. She says, now, what would you do if? All right, you typed in the exact same problem, except you typed in 45,000, right? We get the same answer. Okay? So it doesn't matter how you type it in, you're going to get the same answer. Now, does that make sense to you? Okay. To recap, anytime you use scientific notation, the button you're going to be using is the EE button. And anytime you use raised to the something another power, you have to use that button there, which means caret. All right. Okay, how we doing? You got another one for me? Yes. 28. We can do 28, I think. We'll try it. Sure.
I know that we need to round it.
Oh, rounding?
Do we need to round it?
Now, my philosophy is, and some of my colleagues don't think so, my philosophy is instead of getting all keyed up about significant figures and rounding and all of that, just get a reasonable answer in this introductory chemistry. All right? So many times I've seen professors that they just stretch all this significant figures and everything, and then it's to the point that you can't see the forest for the trees. You're so worried about, am I going to get the right number of significant figures? Is he going to count? Is he going to count off? So I believe at this level, don't worry about it. Now, significant, important, sure. And if you're going to be a chemist, you're going to take quantitative analysis, you're going to get busted with it, all right? But this is not the place to do that. Okay, now what number? Somebody said work a number. 28? Okay. How many days would it take to lose 25 pounds if an average weight loss is 1 kilogram per week? All right, so this is number 28, and here's what I want to do. I want to lose 25 pounds, but my stipulation is I'm losing 1 kilogram per week. How long is that going to take me? All right. So, what do you want to start with? Why don't we just write down 25 pounds? All right, tell me how to get there. From pounds to kilograms.
2.205 pounds.
All right, 2.205, right? Okay, 2.205 pounds. Is this what you want? Per 1 kilogram. Everybody see that? Okay, so that cancels. Now, how much is this person going to lose? What's the rate? 1 kilogram per 1 week. Now, they want to know what? How many days? Okay, so 1 week, 7 days. 79 days? Wow, look at this people here, right? All right, I hope you can still see that without having to cut out the light every single time. So the motion from the floor says, so 25 divided by 2.202, nope, 2.205, times 1 divided by 1 times 7. Look at that, 79.4 days, right? So if you were going on this weight loss strategy, it would take you about 79.5 days to lose this type of weight. Now remember, what we're doing here is something called dimensional analysis. We are not solving these problems with some sort of calculus, some sort of a physics problem with rate and mass and all that. We're solving these problems with thingies on the top will cancel with thingies on the bottom. All right? That's called dimensional analysis. Converting from back and forth. What else have we got? Number 31, well, I want to work it if it's interesting, right? I don't want to work a problem that's not interesting. So number 31 is where we're going. All right. Oh, wow, a competitive high school swimmer. All right. So here we've got a high school swimmer, and again, of course, you would imagine this would be a faster time than a normal human being, probably. All right. Takes 52 seconds to swim 100 yards. What is his rate in meters per minute? So 100 yards takes this guy 52 seconds. And I want to know the rate in meters per minute. Okay, again, we got two units. We got a time and we got a distance. Which one do you want to deal with? Let's deal with the time, okay? Well, here's what I know. I know that there are 60 seconds and 1 minute. Now remember, I want a meter per what? Minute. So I can just go ahead and put a check mark here. My minute is taken care of. So if I stopped right here, I would be in yards per minute. Now that's not what I want. Perfectly good unit, just not what I want. So now somebody tell me how to get from yards to meters. Or do you want me to do it? And by the way, I want to stress that there are 10 different ways to get there. All right? So it doesn't matter what you do. Matter of fact, maybe what I'll do is I'll take a suggestion from you and then I'd work it the way I'd work it. All right? So go ahead. Tell me what you want to do.
1 meter is 1.0936 yards.
All right, so she's got 1 meter, 1.0936 yards. So now I'm in what? Meters per minute. All right, so going back over here, 100 divided by 52. All right, so here's what we got. We got 100 divided by 52 times 60 divided by 1.0936. 105.5. Is anybody getting that? Did I type that in right? 100 divided by 52 times 60 divided by 1.0936. 105.5 meters per minute. So that means every minute this person swims, they would traverse 105 meters. Yes. Yes, it is. Mm-hmm. Yep. 1, 2. So that's the 2. That's the times 2, times 10 to the second. So that's the same thing. All right. Now, if it was me, all right, now I'm just a simple-minded country boy, right? So here's what I'm going to do. I'm going to do 100 yards divided by 52 seconds. And then I'm going to do 60 seconds divided by 1 minute. Now take note, I have not had to memorize nothing. All right, let's take a look at this. I'm a football player, right? How many feet are in a yard? 3 feet, right? We all know that. That's been on the football field. All right. And now look at here. 1 foot has how many inches? 12 inches. Right? So far I've not learned anything I have not learned on a football field. Okay? Now let's take a look at this. 1 inch equals 2.54 centimeters. Okay, now I use something silly. I use something that I learned behind this board in Joe King's chemistry class, right? Because I told you that's the only thing you better